Okay, here's a couple of the quest problems from that assignment that I wanted to kind of work through so that you would have like a go by for some of the other problems in there. These are going to have different numbers for your version. Okay, so if you're working through with me, make sure you're using your numbers and not my numbers. So the first one I'm going to do, it starts out where we have 4 cylinders of a new type of combustion engine, each have a displacement of 3.3 liters. So that where when you're talking about cylinders, okay, and it says it has a displacement of, make that a little bit larger, that is your delta V. So it's already done the subtraction. So that's telling you the delta V. And it says that it is displaced with a pressure of 1.4 kilobars. So 1 kilobar, because remember, to use that equation, we need it in atmospheres, is 0.9869 atmospheres on there. So let's just go ahead and convert that, since we know we got to do it anyway. Okay, so and 1.4 times 0.9867. And so I'm getting 1.3817. Remember, this is Quest. We're not going to round too much. And that's in my atmospheres. And it wants to know how much work can the engine do in 1 minute. So first off, let's just do our work equation, minus P delta V. And again, on this one, it says how much work can the engine do. So they are implying that the work is going to have a negative sign. So when we put in our answer, we're just going to put in the quantity. You do not have to put in the negative. And in fact, I think if you put the negative in, it's probably going to come back and tell you that your answer is not right on there. So we have minus 1.3817 and then minus 3.3 liters. So that's going to give me 3817 times 3.3. So 4.5961 liter atmospheres, and it wants it in joules. So 1 liter atmosphere is 101.3 joules. So times 101.3. That gets me 461.888. That's joules. Now that is 1 cylinder in 1 second based on the problem. So that's the amount of work that 1 cylinder does in 1 second. So we know it has 4 cylinders. So this, it wants 4 cylinders and for 1 minute. So I need to take my answer and then multiply by 4 to get for 4 cylinders. And then I'm going to multiply by 60 to get for 60 seconds or 1 minute on there. So you do those multiplications, and then that is going to give you the answer that you need. Okay, so let me change. I'll move it to red now. All right, so you've got several problems where, and this is the 1 of 6, but there are some other ones too. And so what we want to do is I want to work through a couple of these, and these are even though it's 1 of 6, this one is actually 3 problems, because you'll see that at every other one, so part 1, part 3, part 5, they give you a new setup. So for each of those, you're going to draw a new diagram. So let's look at how do I draw the diagram and answer the question if it's, based on what it's giving me. So starting with the first one here, all right, it's telling me that mine is the delta E forward is negative 14.1. So I'm going to draw that, and because it's negative, that means exothermic. So I know that my relative position is that the products are going to be lower than the reactants. And the way I usually do these is I'm just go ahead and I say, okay, I'm going to make that lower value a 0, and then the upper one, so I know the delta E, so from 0 up to the reactants, that's going to be 14.1. Again, your numbers are going to be different because this is another one where they vary the numbers. And then, all right, and then I know there's a hill, because I always put the hill in. So there I've got my basic diagram. So now what's the other piece of information giving me? Well, the other piece, this says EA reverse is 50. So this is telling me, all right, so reverse, and if I'm going in reverse, I'm actually starting at 0. So this is telling me from there to there is 50. So obviously, right, this is my thing is not to scale, but you kind of get the idea there. All right, so now I've got some number values associated with each piece of this diagram. So I'm going to look to answer the question. Let's erase that line off of that. All right, so the first one is easy because delta E forward and delta E reverse, right, those are always going to be equal in magnitude and opposite in sign. Remember back when we did our rule in the lesson about flipping the equation? When we flip the equation, our delta E or our delta H, the magnitude stays the same, but the sign changes. So for me, if my delta E forward, so if I have the delta E forward is negative 14.1 kilojoules, then my delta E reverse. So really, I didn't even need to draw the diagram to answer that first part of that question. So delta E reverse then would be a positive 14.1. Okay. Then it says it wants EA. So EA, that's meaning no prime, so it's for the forward. Remember, it always is going from the reactants up to the top of the hill. So for this one, my EA is going to be the top of the hill minus my reactants. So for me, that would be 35.9 using my numbers. Okay. And then now, like I said, every other one, it starts a new problem. So here, let's go, let's do green. All right, so now I'm going to use this information. All right, but first off, remember, the first thing it's asking is delta E reverse. So for me, my delta E forward, it says is minus 92.5. So this is going to be a positive 92.5 to answer that first part. But I still got to draw the thing to answer the question. So again, it's negative. So it's going to go here, here, with the hill. I'm going to put the bottom one at 0. And since the delta E, so that would be 92.5 would be where my reactants are, because delta E is products minus reactants. Then my EA, so this one is giving me the forward activation energy. So this is saying that the distance from there to there, that's EA, is going to equal 30, 30.2. Well, what that means then is that the top of the hill, or technically the energy of the activated complex, is going to be 30.2 plus the reactants, which were 92.5. So my top of the hill is going to be 122.7. And so that, which is my forward activation energy. So that's 122.7 is the top of the hill. So now to answer the question for the second part of that one, it wants to know EA reverse. Well, EA reverse, right, is there to there. So it's going from 0 to the top of the hill. So it would be 122.7 would be my EA reverse for that. All right. And then looking at this last one here, all right, so for this one, here it's giving me the EA reverse and the in the and the delta E reverse. So again, I don't need to draw it to answer the first part because it's giving me the reverse and it wants the forward. My reverse is negative 40.7, which means my forward would be positive 40.7. Yeah, again, I'm going to draw here and draw it. Now, this says that the reverse reaction is negative. So if it's exothermic in the reverse, then the forward is going to be positive. So for this one, my reactants are here and my products are going to be up here, right? And so it'll look like that. And then so if I make my reactants 0, that means that my products would be at 40.7 on there. And then it's also telling me that the EA reverse is 33.2. So that's EA reverse. And it's telling me that that is 33.2. So then to calculate what's the value of the top of the hill is going to be 40.7 plus the 33.2. So 33.2 plus 40.7. So 73, my top of my hill, 73.9 is the top of the hill. And then, so now it wants to know what is the activation energy of the forward. So forward is going from the reactants, put it in orange again, up to the top of the hill, which my reactants were at 0. So that means that value is going to be 73.9. Okay.